In the 1860s, the English logician and political economist William Stanley Jevons designed what he called a logical machine, also known as the logic piano. This strange box, Jevons claimed, showed that machines were capable of reasoning. The machine automatically determined the logical consequences of abstract statements such as all A's are B's, some X's are Y's, etc. It's controlled by a small, piano-like keyboard. Each key is labeled with an uppercase or lowercase letter. Uppercase letters are positive, indicating that a category is included, while lowercase letters are negative, so lowercase a means not A. In addition to letters, there are also keys with terms like is and or that connect the categories into logical statements. The keys cause vertical panels to move in and out of visibility. Each panel is labeled with a combination of upper and lowercase letters, representing one possible combination of the categories A, B, C, and D. Together, the 16 vertical panels represent all possible combinations of these categories. If a user types A is B on the keyboard, then all the combinations that have uppercase A but lowercase b move out of place to a position where they're not visible. The display then reflects the newly entered data that anything that is A is also B, or at least it should. After 150 years, the machine isn't working perfectly, so the results we see today are not entirely correct. But if we open it up, the general way the device functioned is still clearly visible. The vertical panels displaying the combinations of letters are mounted on wooden rods that move up and down. Each key press causes the vertical position of certain rods to change, while leaving others unaffected. The rod's vertical position acts as a kind of memory, determining whether it should be affected by the next keystroke. But vertical position is also a way of displaying results. With the cover in place, we can only see the letters on rods in one vertical position. The front panel hides the letters on rods that have shifted up or down. Only the combinations on the visible rods are logically consistent with the data. Imagine for a moment the mechanism still worked perfectly. If we entered all A is B, all the panels showing A but not B would move out of view. Then, if we entered all B is C, the panels showing B but not C would move out of view. We could then see that the only combinations with uppercase A still visible also have capital C's. It is a logical consequence of our data that all A is C. Now, this was not a particularly practical device. Jevons was clear that its value was theoretical. He presented it as proof that mechanism is capable of replacing the action of thought. It would be nearly a century before the makers of digital computers put forward their more famous and more practical efforts to mechanize logic. But even in the Victorian era, it was possible to view a machine as something capable of reasoning.